here we're going to test some equations to see if they're symmetric to the x-axis, the y-axis, or the origin. So first to think about is, if I have a point, what would make it symmetric to the x? Well, the other point, x negative y, would need to be over here, the mirror image across the x. And then same thing for the y, to be symmetric to the y, I would need negative xy. And so all of these set up their own test, meaning if I have an equation, I have to test each of these cases individually and say yes or no. So we'll go one at a time. So symmetric to the x. I want to take where there used to be a y and put a negative y. And if I get my original function back, if the negative cancels, then it's symmetric to the x. So where there used to be a y, I'm going to put a negative y. Well, what happens to something negative to the fourth? The pairs of negatives cancel, and so I end up with just y to the fourth. So did I get my same equation back? Yes. So this one is symmetric to the x. So symmetric to the x-axis. And now we have to test for the y. So where there used to be an x, I'm going to put a negative x. And then same thing, this is negative x to the fourth. So to the fourth cancels the negative. I just end up with 8x to the fourth plus y to the fourth equals 23. So I got my same equation back. That tells me this one is also symmetric to the y-axis. All right, then origin is where I try them both at the same time. Now in this one you might already be able to start to tell, well, hey, didn't it cancel out the x and the y? Doing them both means they'll both cancel. And you're right. Just write it out to show what's happening. So the negative will cancel because of the fourth power in both of these. So I get the same function back. So this one was actually symmetric to all three. So the origin, the y, and the x. So they're separate tests. You have to do them each individually. All right, let's see one that maybe doesn't work for all of them. All right, so one at a time. Symmetric to the x, I have to put a negative y in there. So what happens if I take the same equation? Be careful, this minus is part of the equation. We're plugging negative y in. Well, negative y squared is just y squared, right? The negative cancels. Doesn't affect that one because it's outside the parentheses. So that looks like I got the same function back. So that one's symmetric to the x. All right, now we'll try symmetric to the y. So where there's an x, I'll put a negative x to see if it's symmetric to the y. So negative x, there's no exponent, there's nothing that's going to cause that to cancel. Maybe even if I multiply everything by -1, it'll make everything positive. Either way, notice I'm not getting my exact same function back. So that one isn't symmetric to the y. All right, so then we'll try the origin. So if I put a negative x and I put a negative y, so that one cancels. I have negative x minus y squared, right? Because this one, if I square it. So notice same thing. This one canceled, but this one didn't, so it's definitely not the same function, so it's not symmetric to the origin. So this one's only symmetric to the x. So they're three separate tests. You kind of have to run them separately. You might get kind of used to, once you do a few of them, noticing what type of things, like an even exponent, cancel off a negative for you. But you have to run all the three tests separately.